This is our first lesson in Unit 1415, which is our second unit on statistics here, and this unit is concerned with data analysis. So in 1213, we worked on how you collect data and things to be aware of when you're doing data collection. Now we're interested in what you're going to do with this data, how you analyze it now that you have it collected. And we're going to start here with our first lesson on what are called measures of central tendency. These are concepts you've encountered before. This is good old-fashioned mean, median, and mode, which you used a little bit in Unit 1011. We are going to be able to determine the mean, median, mode for both raw data, and we're also going to look at what you have to do when your data has already been grouped together into a frequency table. And we're also going to talk about when each measure is the most appropriate measure of central tendency to use for your data set. So first off, what is central tendency? Well, measures of central tendency describe how the data is grouped around a particular value. Okay? And that particular value is called our measure of central tendency. And the three most common ones are the mean, the median, and the mode. So the mean, the median, and the mode, what we're looking for with these values is what is the most representative value of the group? What is a typical value from this data set? What would be the data set that is kind of closest to the middle and all of the other ones kind of group themselves around it? And as we said, we've used mean, median, or mode depending on the situation. Now, what affects whether we choose the mean, the median, or the mode? Well, one of the things that can affect it are what are called outliers. And we've run into outliers earlier in our math career. This is just a piece of data that is located far away from the rest of the data, or that deviates from the rest of the data. Or from the trend in the data. So I've got two graphs here that show how outliers pop up in both scatter plots and in histograms. So in our scatter plot, I think it's pretty clear that this person right here is our outlier. We got a nice smooth trend here. We would probably do a quadratic regression to this data here. This guy right here is our outlier. Okay. Now, in our histogram, over on the right-hand side here, we've got a distribution here, a nice little symmetric distribution, and then we've got this one right over here. This is our outlier. This one way down here, it looks like -6 or something like that. So what we're looking at when we talk about central tendency is we're looking at basically where does our distribution kind of center around. Okay? So our measure of central tendency should be somewhere right in the middle of our distribution. And this is an outlier because it's pretty far away from that central value relative to how far all of the other values are. And we're going to be able to make this decision on whether something is an outlier and how far away it is when we talk about variance and standard deviation a couple of lessons from now. So we talked a little bit about distributions like this in the last unit, and we said that something like this with a lot of outliers on one side would be skewed to the left. What causes this skew? Well, often it is what we refer to as outliers. How does this affect our decision of whether to use the mean, the median, or the mode as our measure of central tendency? Well, with symmetric data, as you found in the last unit, the mean and the median and the mode tend to be about the same. So we're going to use either one of these. Either the mean or the median is an excellent measure of central tendency. We're going to use the median if we have skewed data, or if we have data sets with a lot of outliers. And the reason for this is that the median is less affected by outliers than the mean is. often in statistical terms, we would say that the median is a more robust measure of central tendency than the mean is. Okay? And where do we always use the mode? Well, if we've got qualitative data rather than quantitative data, we're always going to use the mode. What is the most frequent category that people answered in? So let's take a look at an example of doing mean, median, mode calculations for some raw data here. What we've got here is we've got a list of test marks. We want to figure out the mean, the median, and the mode, and then decide which one of these is the best measure of central tendency in this case. So I've written the first two steps that we're going to follow here in this box here. First thing we want to do is figure out how many test marks we have in our sample here, and then we're going to write them in order from smallest to largest so that we can get a handle on where our median is, because our median is that middle value. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 marks. Okay. And we can just go ahead and we can write them in order. That's fast. Okay. So we'll do an example later on where I actually show you some tricks about writing these things in order. But basically, you just want to cross them off the list as you go from smallest to largest. And then at the end, you're going to double check and make sure you've actually got 18 marks in your revised list here. So let's start with our median. Our median is our sort of middle mark. Okay, that's fixed. So the median is the middle mark when we write these things in order. So if we've got 18 marks, we're going to have the mark that's going to divide them in the middle is going to be somewhere in between the 9th and the 10th mark. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is the middle of our data set. So our median is going to be the average of those two marks that are on either side of that middle. If there was a single mark that was in the middle, if we had an odd number of marks, we would just take the one in the middle. So we want to do 69 plus 73 and divide that by 2. Punching this into our calculator gives us a median of 71. Now let's calculate our mean. Okay? And a symbol that we usually use for mean is X with a bar on top of it. Okay? X's are all of our individual data points here, and the bar over top just means, well, it means take the average of all of these things. So if we're going to take the mean here, we want to take the sum of all of our individual little x values, and we're going to divide them by the number of x values that we have. So we know the number that we have is 18. We can just punch all of this stuff into our calculator, adding them all up. So we add them all up, we would get 11,158. Divide that by 18, gives us a mean of 64.3. Our mode is the value that occurs most frequently in our list. And this is another good reason to write them in order, because when you write them in order, you can easily pick out ones that are the same, that are reoccurring. So we have got 61 occurring twice, and we have got 80 occurring twice. So we have not one mode, but two modes, 61 and 80. So if there's more than one mode, we just list all of them there. Okay. Now, if we look at this data set, which one do we think is the best estimate of central tendency here? What is the most typical, what is the measure that is going to best represent the center of this distribution here? What do we think? Kale, what do you think? Why do you say the median? It is in between the two modes. Yep. Yep. And it is, well, if our median is greater than our mean, what is causing our median to be greater than our mean here? Do we have any outliers in this data set? Any numbers that are far away from the mean or the median? Alana? Which ones? Yeah, 12 and 15 right at the beginning here. Some people did really, really bad on this test. I don't know what they were doing here. Maybe they didn't study. But we've got these two outliers that are causing our mean to be considerably smaller than it would be, than we would ordinarily expect. So in this case, the median is probably the best estimate of central tendency. Therefore, we'll just say median is best due to the outliers.